Hey AP Stats, Mr. Zmudio here, and we are continuing with our lesson, and we are doing Chapter 5 Notes. We should be on page 4. So we should have completed the first 2 pages by now. The first one we did in class. This one was an Edpuzzle. This one we did in class on Tuesday. And then this is your homework for Tuesday night. So, let's go and get started here. In this example, we have the mean score in a college level statistics class for the first test was 75 points with a standard deviation of 5 points. So we have a sample statistics class, and we know that mean is 75. So I'm going to say my X bar is 75. That's my mean. And my standard deviation, denoted as this S subscript X, or S sub X, is 5. Okay, so if you score 83 points on the first test, calculate your z-score and explain what the z-score means in the context of the problem. From the lesson that we did in class today, you should remember that z-scores are basically how many standard deviations away from the mean are you. So if I were to quickly kind of put 75 here as the mean, 76, 77, 78, 79, 80, maybe 81, 82, 83. If 75 is the mean, and we are over here, and one standard deviation is 5 points, well, if I was at 80, I would be one standard deviation away. My z-score would be positive 1. But we can see we got to go a little more, so maybe about 1.5, but we can actually figure out what the value is. And we can figure that value out by using that z-score formula. So remember that z-score formula is z equals your value minus your mean over your standard deviation. So again, for this one, we're looking at a z-score of about positive 1.5. Let's see what we get here. So my z-score of 83 is 83 minus the mean, which we said was 75. And we divide by our standard deviation of 5. And then this, you can put in your calculator or do it mentally. 83 minus 75 is 8. 8 divided by 5 is 1.6. So we have a z-score of 1.6. And what that means is that a score of 83 points is 1.6 standard deviations above the mean. So the score of 86 has a z-score of 1.6. Which means it is 1.6, abbreviate standard deviations. Standard deviations above the mean. And if you remember from one of our examples, in order for something to be unusual in statistics, it's got to be more than 2 standard deviations away from the mean. All right, let's look at this next example. So our friend scores 70 on his test. Let's calculate his z-score. So using that same formula, I'm going to use my value minus the mean. So my value is 70 minus the mean of 75. It's the same example. Divided by the standard deviation of 5. Okay, now this one I am going to show my work a little more, just because we do get a negative number in the numerator there. 70 minus 75 is negative 5 over 5. And what this gives us is this gives us a negative z-score. I'm going to draw the picture up here. You don't have to draw this right now, but this value of 70, 2, 3, 4, 5, here's 70. And remember, one standard deviation is 5. This value of 70 is exactly one standard deviation away from the mean, but in the negative direction. That's why we got a z-score of -1. So z-scores that are negative mean they're below the mean. Positive z-scores mean they are above the mean. So let's say our friend's score of 70 has a z-score of -1, which means it is one standard deviation. And I gotta use that word below. Below the mean. Alright, so 75 is our mean. We know the standard deviation is 5. And remember, in stats, I've told you that in order for something to be unusual, when we're talking about the mean and standard deviations, it should be more than 2 standard deviations away. So thinking about this problem, if I was at 75, 2 standard deviations above 75 would be 5, another 5 would be 85. And 2 standard deviations below this would be 70 and then 65. Let's put the 65 right here. And basically what this means, guys, is if I had any number that was higher than 85, it would have a z-score of more than 2, and that number would be pretty unusual. And on the same note, if I had any value that was lower than 65, it would have a z-score of less than -2. That would be unusual. You can think of these values where the z-score is -2 and +2 as similar to your upper and lower fence, in that any value outside of that becomes unusual. Alright, last question for today is our friend tells us that their z-score is 2.8. So think about this. He has a z-score of +2.8. Explain what their z-score means. So our friend scored, we don't know what his score is yet, but we know that he scored 2.8 standard deviations above the mean of 75. So he was actually outside of this 85 value, which we said 85 had a standard deviation of 2. So 2.8, we know he did pretty well. He at least scored higher than an 85. And I know that it's positive because the z-score they gave us was a +2.8. The last one here, can you determine your friend's test using the z-score? I think the question was supposed to say, can we determine our friend's score using his z-score? And we can actually figure out what that value is just by, again, using the formula. And this formula is going to be extremely prevalent in our course. Like this is definitely not going away. So let's just remember this. Our z-score is our value minus our mean over the standard deviation. And in this example, they actually gave us the z-score. So we just got to plug in the 2.8 for z. And what we don't know is we don't know the value. We don't know x. We don't know what his actual score was. But the rest of the stuff we do know. We know the mean and we know the standard deviation, which was 5. And then this is just a matter of algebra. I'm going to get rid of the 5 by multiplying both sides by 5. 2.8 times 5 is 14. Add 75 to both sides. So we have x equals 89. So our friend scored 89. Alright, that's it for today.